In this video, we're going to introduce density, which is a type of property of matter. So before we introduce the definition of density, I want to introduce two different types of properties that matter can have. Those two different types of properties are known as intensive properties. So you have intensive properties and you have extensive properties. So extensive properties. And these differ in the aspect of whether they depend on the amount of the substance that you have. So for extensive properties, these are properties that depend on the amount of matter you have. So these depend on the amount of matter. Right, so think about a property like mass, right, or volume, right? The more you have, let's say you have a lead block, right? If you have a bigger lead block, that's going to have a larger volume, a larger mass. These are extensive properties. If you're characterizing the mass of something, if you have more of that object, then it's going to have a larger mass, right? Two baseballs would weigh more than one baseball. These are different masses. They depend on the amount that you have. Now, extensive properties are properties that do not depend on the amount of matter. So these do not depend on the amount of matter. Right, so a simple example of this might be like color, right? If you have something that's blue, then it doesn't matter whether, like, so for example, water being the color blue. It doesn't matter whether you're talking about, a blue ocean or blue lake, it's still going to be blue, regardless of the amount of water that you have. So color would be an example of an intensive property. Now, one way that you can create an intensive property from extensive properties is to take the ratio of two extensive properties. So you can create an intensive property by taking the ratio of two extensive properties. And this is how we get to the definition of density. So density is defined as the mass of a substance over the volume of a substance, right? So these are two extensive properties, right? Mass and volume both change with respect to the amount of matter that you have. And then when you take a ratio between those two extensive properties, you get density, which density is an intensive property. So density is intensive, and it's built as a ratio of two extensive properties. So this is the general definition of density. So let's look at an example of density in action. So let's look at an example problem. So this problem says a rectangular block has dimensions 2.9 centimeters by 3.5 centimeters by 10 centimeters. The mass of the block is 615 grams. What are the volume and density of the block, right? So we know that we have a rectangle. So I've drawn a rectangular block here and I filled in its dimensions based on what was given in the problem. So we have 2.9 by 3.5 by 10 as the length, width, and height for the rectangular block respectively. So we know we have to calculate the volume. So let's do that part first. So we want to first calculate the volume. And we know from our definition of density that we're going to need the volume to calculate the density anyway, right? So we're going to need that volume regardless of whether they told us to calculate it or not, but they told us to do it. So we'll go ahead and do that. So we want to calculate the volume. So the volume for a rectangle is just going to be its length times its width times its height. right? So basically you're just going to multiply all three of these numbers together. So you're going to have 2.9 centimeters times 3.5 centimeters times 10 centimeters. Right? So basically you're going to multiply all of these together. When you do that, you get 101.5. Now, oh, I put an extra decimal there. Don't want that guy. Okay, 101.5. Now let's think about the units here. So when you multiply three units together and they're all the same unit, you're going to multiply the units together as well. So you have these three numbers multiplied and you have the units multiplied. So that means that our volume is going to be in cubic centimeters. Now, cubic centimeters is actually the same as milliliters, but here I'm going to leave it as cubic centimeters. So we have the volume. Now, at this point, we have the volume. So what we want to do is calculate the density from there. So we're going to calculate the density. And let's ask ourselves, do we have everything we need to calculate the density? So we know density is going to be mass over volume. We've just calculated the volume, and in the problem, they gave us the mass of 615 grams. So we do have everything that we need to calculate the density. So let's do it. Density is equal to mass over volume. So we're going to have 615 grams as our mass and 101.5 centimeters cubed for our volume. And so that will give us a density of 6.059. And as far as the units for density, those units are always reported as mass over volume. So this is going to be grams per cubic centimeter, right? So whatever this material is, regardless of how much you have of it, this is the density of that material, 6 grams per cubic centimeter, right? Another one that you can think of that's popular for your the velocity of your car, right? Miles per hour, right? That's how many miles per hour you're going. Two extensive properties there that give you a ratio to form an intensive property. So, keep in mind this density is intrinsic, an intensive property for whatever the actual type of matter our rectangular block is. So that's an introduction to density and an example problem of being able to calculate the density of a given object.